All right, let's get started. Welcome back. This is the final portion of the lectures of the class. So we have 4 lectures left, and this is actually the starting to get to the really exciting modern part. So recall that we've learned a lot of about the history of the web and a lot of the underlying technologies that are below, that kind of lie below a lot of the stuff, the websites you're using, and the stuff you're probably going to use in your projects. But really, if you're actually going to get a job or an internship as a web developer nowadays, you will probably not directly use those technologies we learned in the last 8 weeks or stuff. Those are just the concepts that underlie all these frameworks you're going to be using in your job. So in this final part of the class, what I call Web 3.0, which is not a real term, I just made this up, which I call Toward a Composable Real-Time Web. This is starting to introduce some of the concepts in modern web development over the past, let's say, 5 years or so. And what I really define modern web development as is, one is composable, which means that people are nowadays not coding websites and apps from scratch anymore. They're building and composing all these different components and parts together. In real time, what I mean by that, we'll cover in the next few lectures, is that websites nowadays are way more interactive than they used to be. They have this sort of two-way real-time interactivity, much like regular desktop apps, so even much more interactive than the Ajax apps we saw. So in these last 4 lectures, we're going to explore these ideas. And so today is lecture 9, which is Web Services and REST APIs. So I'm going to go over the calendar to show what's going on. So recall that after exam 1, we had this mini lecture 8, which finished up the Web 2.0 part. And this is about local storage and HTML storage. So recall last time we did, which is about a week or 2 ago, is we use HTML5 storage, which is called local storage or session storage, to store persistent data in your browser without sending anything to the server like cookies do. So this is a much more modern technology than cookies and more lightweight. And there is a code example online that you should all, beyond just these readings, you should all study this code example for exam 2. So you'll be responsible for understanding this code example for exam 2, because this is right after exam 1, so this is lecture 8. And then what we're going to have is we're going to have this Web 3.0 area, which has 4 lectures, which is lecture 9, which is today, 10, which is Thursday. There's no class on Tuesday. Your projects are due. And then next Thursday and next Tuesday, 11, 12, and we'll have exam 2, the end of October. And that exam is going to cover 5 lectures. So lecture 8. So remember, don't forget lecture 8, because even though it wasn't part of this topic, we didn't cover it in exam 1. So lecture 8, plus the 4 lectures in this most recent part. And then after the exam will be the final project period. But remember to get your project milestone 1 submitted on GitHub. The instructions are online next Tuesday. So that's the roadmap for the next 4 lectures. So we're going to get started today with this idea of web services and APIs. So the learning objective today is to make your web applications richer by leveraging web services and APIs that other organizations created. This sounds like a really empty buzzword marketing sentence, which it sort of is. So I want to actually spend today making this a lot more concrete. But today's going to be a lot more of a conceptual lecture, so there actually will be no coding today. There is a set of lecture notes that I uploaded, so you should definitely study that for the test. So I just wrote up a bunch of lecture notes online. I'm actually just going to go over those lecture notes in class. So instead of studying code for today's lecture, you'll have this document which is on the website to study for the exam. And this was last time. So today's outline is the following. So we kind of did this introduction Web 3.0 thing, which is the topic we're covering now. And then we're just going to go down this list here. So first of all, forgetting the web in general. So So the first thing I want to cover is, what is an API? So do people have ideas about how to define this term? It's sort of a hard to define term again, but ideas about, if you hear the term API, what do you usually think of? Yep.
Kind of like a framework to utilize an already set resource within your web app without having to start from ground zero.
Good.
Wow, that was a horrible.
That was good. Ground zero. Yeah. Well, yeah. So you mentioned some framework, some code that other people wrote, right? So you don't have to start from scratch. Good.
Already defined methods for like a certain library or whatever.
Yeah. Good. So we have already defined methods, libraries of code. Do you have something back there as well?
It was a similar definition. It's the already defined methods, but in that case we don't have to implementation that you just have to use those libraries.
Good.
UI.
Good. So we're converging. So we have this idea of code that other people wrote that you don't have to reinvent the wheel or start from scratch. We have libraries with the term methods, functions, and your mention that you added was that you don't have to care about how they implement it, right? You're just using these as modules that you know, just throwing out more empty words, modules, methods. All these words are confusing. They basically mean it saves you work, right? There's stuff that other people wrote, and you don't have to write it yourself. So yes.
What's the difference between an API and a library?
Yeah, that's a great question. So an API, which stands for Application Programming Interface, what you can think of as an API is the interface that the library exposes to you. So you have a library, right? So a library in desktop programming is just a bunch of code. It's just like a bunch of ones and zeros or whatever. The API is really the layer that the kind of interface, because I stands for interface, that your code uses to communicate with that library. So the API is, one can argue that API is documentation, right? An API says, here is how you use my library. You call this function, you call this parameter, you expect this thing out. But the library is the bunch of code itself. So back to your point is the library is what the other person implemented, and the API is your view of that library. Do you have a comment or question back there? Very good. Yeah, so the API is, so we're basically getting to the point where, the first comment mentioned the web, which is what we're going to actually get to. But the APIs, the important thing to realize, the APIs exist independently of the web, right? APIs and libraries are in any language, any kind of programming. You're making an operating system, you're making a game, you're making a handheld phone, you're making hardware, you're making websites. You're probably using some library or framework of code that other people wrote. And then in order to interface with that, you need some kind of an API so that you can know how to use it. So what are examples of some APIs that people know about?
Like video game engine.
Video game engine's good, that's one. Yeah.
Twitter, yeah, Teapot.
Twitter API, right? Okay, good. So you're already getting ahead of me to the web stuff. So how about non-web APIs? It's actually hard to think about nowadays. Everything's web, yeah.
Natural language toolkit one?
Yeah, so natural language toolkit. So this is the Python one, right? Is it? Yeah, so, wow, what's happened? Yeah, so let's actually just keep putting them up here. I can't spell. That's actually a really good one. So this is I think it's Python, right? So this is a library for doing natural language processing, and it exposes an API, which is, where's the documentation? So somewhere is the documentation. API, there you go, API, perfect. Good. So, and we'll have a game example as well. So basically, as you all mentioned, libraries are code that other people wrote that you can take. And the API, what really an API is, it's sort of documentation of how to use these libraries. So this is the API for NLTK. And this basically says, here are the classes, right? Here are the methods on each class. Here is what everything means. They should hopefully give you a tutorial too somewhere, but this is just a reference. So if you notice here, nothing here tells you how the library is implemented or who implemented it or why. It just tells you here's how you use it. You use the interface by making a class and calling this method and expecting these parameters. Another one, the game one someone mentioned was, not super familiar with games. So this is some Java game library thing. There's also things like Unity and other sorts of open source game libraries. This one I've never used before. I just looked for a Java game library, and it's some library, and it has an API somewhere. I can't find the documentation. The idea is that there's a source code getting started. So there's some documentation for here's how you get started. Oh my God, there's a lot of code. So here's how you write hello world in this. You call these methods and functions and whatever. So APIs you could download from third-party libraries like NLTK or this one. Most programming languages come with an API, and it's what's called its standard library. So if you think about what a programming language is, by itself, a programming language doesn't do much because it just defines the syntax and the compiler and the semantics. In order to actually do anything with the programming language, you need to call functions or methods. So this is everybody's favorite API, standard library, is the Java one. This is probably one of the biggest ones in existence. So this is Java version 7 API specification. So this, if you memorize all this, you will probably not get a job or something. But this is gigantic. I mean, this has thousands and thousands of classes and methods. created over, I think, 20 years or so. So this is the Java API. So if someone asks you what is an API, it is that. It's 10,000 pages of documentation. And if you make your way through it, you can know how to create, a font object, maybe. And with these crazy options, and you zoom in, and it tells you what all the classes are, all the methods are, what everything means. And this is a formal specification for how you will use this font making thing in Java. And there's all sorts of stuff in the Java Standard Library for data structures, GUIs, events, multi-threaded processing, UI things. So this is called the Java Standard Library, and the API is how you interact with this here. So basically, every language has some API for you to interact with it. So how many of you have worked with the Java Standard Library? I guess it's probably required for some class here or for other projects. So these are the APIs I've been talking about mostly are for desktop or traditional applications. So you mentioned Twitter, which we'll actually go into very soon. You're previewing my tabs. So normally when you think of programming on the desktop, you think of getting some programming language, downloading some package on your computer, installing it, and then using your programming language and importing the module. So for example, I don't have where's the getting started? This also is a test to see how good the documentation is. Oh my gosh, what is going on? Okay, I guess this works maybe. So usually what you do is you install the right package, and then in your code, you do some kind of import statement, right? You do some kind of, this is in Python, you import some object or something from the API, and then you can start creating objects and calling methods on it. And then you actually pull that in. So, if you remember writing Java code for your other classes, there's like a bunch of import java.lang.star, import whatever. And that's just to grab all the functionality, because the language itself built in doesn't have much. It just has like integers and loops and stuff. So you can't actually do that much with just the language. Okay, so this, clearly libraries and APIs have been pretty beneficial for desktop programming for bazillions of years, because otherwise everyone would have to write everything from scratch. So today what I want to introduce is this idea that some people have already previewed of a web API, or otherwise known as a web service. One of the annoying things about web programming is that people have 10 ways to call the same thing, but so you might refer to this as a web service or a web API, but it basically means the same thing. It basically means the same concept as these libraries, except we actually access them over the web instead of importing something on our computer and like importing libraries. Yeah, question?
Does that mean you have to be connected to the internet to be using them at any time?
That's right. So to use these web APIs, you have to be online. That's right. Yeah, so that's one restriction. So you can't use them in a pure desktop app without internet access. That's a good point. Yeah, so the way to think about the 10,000 feet overview of web APIs or web services is it's the same idea of these libraries and such, except it's all over the web. So what are some examples of this? So let's actually go into, Jim.
Isn't jQuery an example of how we use it?
So this is actually a great example. So actually, let's actually talk about jQuery. That's actually really good. So let me go down here. So jQuery, as you all have used so far, this is interesting because this is a library and there's an API in it, but you can actually use it offline, right? Because you can download jQuery to your computer. So what actually happens is, we're going to draw the dreaded laptop diagram again. The dreaded laptop diagram. So what jQuery is that you have a browser, and your browser is, blah, blah, blah. Your browser runs one language, which is JavaScript. And inside of your browser, you can import JavaScript libraries, right? You can import jQuery, you can import whatever. All this code runs within your browser, right? So all the jQuery stuff and everything runs within your browser. So it's as though the jQuery thing is an API like all the desktop APIs I've showed you. It's just like a Java API or a Python API or whatever. Because as far as you're concerned, as far as jQuery is concerned, there's no internet that's needed. That you can actually just run this all in your browser. So it's as though it's just a library for just a program on your computer. Does that make sense, or you want to clarify that? So it's a little confusing because a lot of times when you include jQuery, you're actually including it from the web, right? You're actually saying like code.google.com/jQuery. All that does is just downloads the library to your computer. so that you don't have to download it yourself. But jQuery actually, I would say it's not a web API or web service because it's just like a normal library on your computer. Yeah.
But when we called it in the Python code we were using, didn't we have the source of it as like the website? So would that be using it as the web version versus us having to download it?
Yeah. So you mean this right here? Yeah. So the thing with jQuery, this is actually important to clear this up. Where is the code? The code is, well, it's all the same idea. But basically, was your question about the script source? It's on the web, right? So a lot of times when you're doing jQuery, it looks like you're just getting the source from the web somewhere. You could also, like I demonstrated, you can also just download jQuery to your computer and just reference it from your computer. So this actually does the exact same thing. So this is not actually doing anything different. It's just that if you don't want to download jQuery to your computer, this thing just downloads it to your computer when you visit the site, but it still runs on your computer. So it doesn't do anything different.
So after you run that once, you could take out the first. Like,
Technically not, because the cache on your browser doesn't know that you downloaded it. So you should. Well, what happens after you run it once? Even if you have that same line, when you run it again, it'll use the version that's saved in your browser's cache, so you don't go on the internet again. But you shouldn't change the line, I guess. So yeah.
Is there any performance difference between downloading API and user reference from
It's for the jQuery example, or for any example. I think that, usually, we won't go into performance metrics in class. Usually people recommend to do this. And the reason why they recommend for you to do this is because other websites that your users visit might use that exact same URL, so they actually have a cache on their computer already. But if you use just this, we can do this offline as well. If you use just this, then somebody is downloading this jQuery from your computer, and then they can't reuse it. But it's usually, it's counterintuitive, but it's usually best practice to actually have the real URL, even though it's counterintuitive. But I don't want to harp on that way too much. But basically, it's just to say jQuery should not count as a web API for the purposes of this class. It's just like NLTK or whatever library, or the Java library downloaded to your computer, because it's running on your computer, on the browser. Okay, so web APIs. Let's see. So non-jQuery web APIs. Okay, so here is a website. Okay, so we got the Java APIs, the giant one. Some game library API. Okay, so this is some website. Crazy ads. It's called Programmable Web. This is a world's largest API repository growing daily. I just clicked on the most popular ones. These are the most popular APIs, I guess, based on some rating. So these are the usual suspects you might suspect. There's Google Maps, Twitter, as you mentioned, YouTube, Flickr, Facebook, Amazon, okay, Twilio, Last.fm, eBay, Twilio SMS, Bing Maps, Delicious, Google App Engine, blah, 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 Google. So basically every major website you visit exposes some sort of an API over the web. And they do that so that people can build applications using its functionality. So for example, if you wanted to build if you wanted to build a social app that's like a social game, you don't want to build your own version of Facebook. You want to just use other people's Facebook accounts and log into Facebook. So to do that, you need to somehow use Facebook as a library, because Facebook has functionality for, yes? With a Connect, like the Microsoft Connect? I don't think so, because the Connect would be, I haven't actually worked with Connect myself, but I would rate it as just a desktop thing, because you plug it into your computer. Like, you mean the thing where it senses the motion? Yeah, I think, that's a good question. I haven't looked into detail, but I think the normal way you use it is probably not a web service, because you're just plugging it directly to your computer. And the software you're running is the interface with the Connect. Now, that said, they might actually have a web API if, for some reason, they might want to allow you to turn on your Connect and someone else over the web to like spy on you or something. Maybe they have that for like multiplayer games. I don't know. Maybe they actually do. But just on the top of my head, I would rate that as like a regular API on the computer. But it could be a web thing as well. But I wouldn't normally think of it as that. And so similar to your Connect question, there are APIs for any hardware device, right? So imagine like if you want to program a 3D printer or something, right? If you've got one of these new 3D printer things, you connect it to your computer and you want to write code that controls the 3D printer, there's probably some library that you need to call, like move printer, raise ink, lower ink, whatever. That's using the printer's API, but that's usually not over the web. unless you want to print stuff remotely, which is pretty cool. All right, so these are some of the major, usual suspects of APIs. So I'll just go to their websites. This is the Google Maps web service APIs. So they call this web service and API, and they usually have varying levels of documentation. You would hope that these big companies have good documentation. So what kind of services or APIs does provide? Geocoding. So this allows you to call functions that convert between addresses and coordinates, which seems pretty convenient. So if you're want to make some kind of a geographical app, you don't want to write your own code for converting GPS coordinates. You can just make some function call to Google and they'll convert it for you. Elevation, okay, elevation data, great. Distance, time zones, roads. So all the stuff you imagine that Google Maps provides for users, it actually provides as a library for programmers as well, which is pretty cool. I haven't used this personally, but seems pretty good. Geolocation, so that's Google. This is the Twitter API. So we're going to get into this word REST in excruciating detail throughout the rest of the lecture. So for now, just notice that a lot of these APIs use this term called REST, this mysterious term called REST in their names. So this is the Twitter API. This seems to be what you would expect, so such as, where's post status? So post media upload. Did I miss post status? Yeah, there we go. Post status update. Okay, so this is a function call thing for fancy way of saying updates authenticating users' current status, also known as tweeting. So if you make this function call to the Twitter API with the right parameters, you will send a tweet under your name. And so why would you want to do that? Is because if you're making a Twitter app on your computer, you want to have some user interface to enter a tweet, and you need to call this API so you can actually send the tweet over real Twitter. All right, yes?
How does it benefit Google to provide services like that?
Good. How does it benefit Google or Twitter or other companies to provide all of this for free, right? Two ways. So Twitter actually, I don't know how their business model is going because they just laid off a bunch of people, but they one of the things they do is they charge for APIs. So APIs can be a business. So for example, if you're an advertiser or something, you can pay $1 bazillion to get unlimited access to Twitter API, and then you can write code in your spam organization to crawl people's statuses and spam them. If you want to do it for free, you have what's called a rate limit, right? So where's rate limits? So anybody could use a Twitter API. I think you have to have an account, but here is the actual rate limit. So this is how many function requests or function calls you can make per 15-minute window if you have a free account. And if you pay for it, you might get unlimited or something. So one way is you can pay for APIs. Another API that someone pays for is there's this company that does geocoding. I think it's probably more detailed than Google Maps, and you pay $1 bazillion to use a web API to query them for really accurate geographical information. Google provides, I think, probably all APIs or most of them for free. So how would it benefit companies to provide APIs for free? One way it benefits something like Google is you want developers to build apps on top of your API, right? Because then it makes your platform more popular because more people view your ads. Yeah.
Would credit have to be given to Google for if someone used their API? Here's this app, and in the details, we use Google API to make this work.
That's a good question. Sort of a licensing question. I think for your class, you should document it because that's part of the class project. If you use external code or APIs, you should just document it. It's definitely allowed. You should definitely use this if you like Google Maps and stuff. But yeah, you should document it for your class. In general, I think for if you're selling a product or something, I think the licensing, it depends on the fine print, the legal print, right? Usually they're okay with you just using it because they know you're using it because it's in your code. Some APIs might, some companies might say it's free for non-commercial use, like if you're a random project, but if you're actually a company using it, you have to pay them. And so if you're an actual company, you don't want to get sued, you should pay them. But it depends on the license. But yeah, for this class, if you use a Google API, just say in your report, we use a Google API. Yep.
I read something else of they want everything to be open source, so if you made a really cool app, they can just hire you to work on the main project.
Yeah.
So letting people have experience with it beforehand.
Right, so that goes back to your question of this is called, in general, this is a subfield called developer evangelism or tech evangelism of you just want your platform and tools to be used by as many people as possible because you could hire people because if someone makes an awesome Google Maps app, then you could try to hire them or you could just, work with them in the future. Yeah, do you have a question?
So for APIs like this, assume I use one of them, and when the user trying
question. What happens if the server of like Google or jQuery shut down?
Mhm.
Is the web application still going to work?
Yeah, that's a great question. So part of using these web APIs, that's a really good question, is part of using it is that you're relying on their servers to be up, because it's kind of going back to the offline thing. If their servers like blew up, then someone goes to your web app and it just stalls or something. So part of your code should be to check whether it's up and just say have an error message if it's not. So that's part of kind of defensive coding on your part. But yeah, you have to rely on them. And that's probably why for some of these services, they charge for APIs. It's like maybe if you pay for Google's or Amazon's API, it's guaranteed to be up, or you can sue them or whatever. But if it's free, it's not guaranteed to be up. But yeah, outages do occur, right? Sites will go down. So yeah, it's as good as their site is. So you're adding a dependency on their site, but what you're gaining is you're getting all their code. So yeah, so I think that's one difference between the desktop APIs. The desktop APIs are all on your computer, so you know it works. Questions?
So,
Yep.
so is it still going to display anything on the browser? Or
If their code breaks.
like error message?
It's up to your code how you handle it. So I think so for example, if you make like an AJAX call or something and it breaks, or if it's not found, there's like an error handler, then you should be able to pop up a message saying it didn't work or something. So yeah, it's up to your code. So yeah, all the error handling should be your code. And part of the API, actually, getting back to your question, is part of the API documents what happens when there's an error. Well, I guess it doesn't document what happens when the server's down. But if you like pass a function with bad parameters, it should say, give you a 500 error or something, and you catch that, just like catching exceptions in your code. So the point I want to get is really it's like programming on your desktop computer, except you're over the web. So other APIs, let's see. So there's Twitter, there's YouTube. Wow, it's really bright and red. What can you do with the YouTube API? Play videos, add YouTube data, do analytics, do live stream. Okay, so you can do all sorts of stuff. GitHub also has an API, so you can imagine writing a project to push code in GitHub or check code out of GitHub. Flickr for pictures. There's an API. There's all these methods. So if you look at these APIs, they kind of look like the Java one, right? They look like a bunch of methods and objects. And then again, once again, there's this weird, mysterious REST term that keeps on coming up. There's blogs, cameras. You basically, the way to think about APIs is it's a bunch of functions and objects that let you do stuff by programming. So you can basically the name of the site is the programmable web. It basically is you can program using all these websites. Facebook is really popular as an API, so a lot of Facebook apps are built on that. LinkedIn, which is like Facebook but for boring adults, also has an API. So you can add spammers to your LinkedIn account. But yeah, so if you notice, every popular website usually will expose some kind of API, and for a lot of the reasons we mentioned, that they want their platform to be popular. So Google Maps wants to be more popular than whatever Microsoft Bing Maps or whatever, so they want their API to be really good. And they have people working full time on this to publicize their APIs, to go to conferences, to give students access to them because they want you to use their ecosystem. Yes.
What if this API breaks down, the links up crash? So can we so our program will also crash the big part of it?
Yeah, so that's kind of back to your question about is you have to handle it yourself. So you have to it's sort of like if you make a function call with bad parameters or something, your function crashes. So in Java you might do a try catch to catch the exception. So in your scripting code you might want to catch some exception that says and then just display a message saying, oh, it's not working. Because if you sometimes visit sites and something doesn't work and it half breaks, so that you have to catch all the errors yourself. But hopefully, if you use these APIs, these ones from big companies are usually reliable enough that if you're demoing it to TA, it should be working. Fingers crossed, unless something really blows up. But yeah, if you're using some API that someone is hosting in their dorm room and they trip over the plug and breaks, then yeah, it's probably not great. But these companies are probably pretty reliable.
Is it possible there are viruses in the API?
That's a good question. Is it possible there's viruses or other bad stuff? That's a great question. Yeah, so it's as with all things with security, it's as much as you trust the endpoints and also the transmission. So hopefully these APIs are transmitted through secure HTTPS, so that will hopefully eliminate a lot of the man-in-the-middle sort of attacks. Then it's just, if somebody is bad within Google and sneaks in some crazy code, so when you call a function, it does something crazy, then yeah. So security is always the question is there possible that there's malware viruses, there's always possibility. It's always possible. But, you know, it's as much as you trust these companies. I mean, you could, you know, if someone, I mean, this is not just on the web, it's like desktop. If I said, here's a library of code for Python that I wrote, that's awesome, and here's the API. It's call this function, and it's great, it'll do graphics processing, whatever, but my code is delete your whole hard drive. You call the function, delete your whole hard drive. Right? It's too bad, right? You just have to trust that I don't give you code like that. But nothing prevents that, except for the browser security. Okay, so this is the kind of overview of API. So this is kind of very high level, you know, how does this, you know, what are they, how does it work? So we want to actually get into we want to actually get into the nitty-gritty of how they work. So how should you actually call these APIs? So the way that these APIs work is an API for a language like, whoops, let me just go back to, where's my Java example? Just closed it. Where's the Twitter example? An API for a programming language looks like a bunch of function calls. So let's say Java. This is probably not the best example because it's so giant, but you know, if you play along to call an API for a language, you may do something like, I don't know, x equals new, you know, list with something, and then x dot. I don't know if this is actual syntax, but x dot append something or something. So to make an API call in a regular desktop programming environment, you create objects and you call functions in your code. To actually use a web API, what you do is you actually make HTTP requests. So web API, instead of calling a function, you're actually making an HTTP request, because HTTP is the language or the protocol that the web works on. So instead of making a function call by, you know, putting parentheses, you're actually constructing some URL and making a request to that URL, and you're getting some response back. So this picture looks very similar to the website visiting. So without further ado, let me draw this one down here. Okay, so let's add to our crazy picture here. So this is the picture we all know and love here. So this is your server for your code. So this is you know, your server, and this is, you know, the user's browser. So recall that there can be a bunch of users hitting your server at the same time, right? There can be a bunch of users visiting. So each time someone, so this is your server-side code, right? So this is Python or PHP or Ruby or whatever you want to write your server code on. When the user visits your site and visits a URL, they make a request to your server, and then the traditional model has been, this is all HTTP. The traditional model has been your server does some processing and then gives them back some data. So in Web 1.0, it was a full web page. In Web 2.0, it was some AJAX bit of data. But this is how everybody communicates with your server, right? This is the picture we all know and love a billion times over, right? Everybody's communicating with the server. So this is all great if all the code you write on your server is yours. You just load any Python code you want, PHP code, Ruby code, whatever you want on your server. But if you actually want to access, let's do a Facebook API. Let's do a Facebook one. So if you actually want to have your server code do something more sophisticated like query Facebook or query Google, you actually need to call some code on, let's call this Facebook server. So Facebook server, and this is somewhere around the world, you know, buried in some data center or under the ocean or wherever they have their servers, which is probably all over the world. Your server needs to now make some kind of request, HTTP request, to the Facebook server, and the Facebook server gives data back to your server. And then what you do is that your code on the server end crunches it and then gives it back to the browser. So if you want to take advantage of Facebook, this is sort of the model you want to think about in your head. So you want to think about Facebook server somewhere. So you want to think about, whoa, I just erased something. You want to think about the browser goes to you, makes an HTTP request, then your server does some code execution. It makes, it says, oh, I need to get some data from Facebook. So then it goes and makes an HTTP request to Facebook. Facebook crunches some data and takes your request. Then it returns the data right back to your server because that's who called it. It doesn't know who the browser is. It just knows your server. Then you crunch some more data and then you bring it back to the user's browser. So I just want to make sure everyone's clear on this flow. Browser goes to your server does stuff, goes to Facebook. Facebook goes back to your server. Your thing goes back to the browser. Yes?
Quick question, so maybe going back just a
Yep.
teensy bit, but say your server's written in C, you said it creates an object, but doesn't C not have objects, just have structs, so what is then called, I guess, by you? Is it only methods, or how does that?
Yeah, so the question is, what if you're in C or something? So the thing with these web services, actually, I'll step back, that there are no such things as objects or methods or everything. The only thing for a web service is an HTTP request. So in your C code, you can make structs or make whatever you want. But if you want to use Facebook, you don't actually create objects. You just make an HTTP request to Facebook server. And this HTTP request is like all requests. It's get http facebook.com / some blah, 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 some data. And that's the interface. So any language should be able to make an HTTP request. I mean, in C, you probably need to import some library to construct a URL and then send it over the web, and then send it over the internet, and then have it come back. Does that make sense?
Yeah.
So basically the API here, so I would say that the API is at this level, is at the level of we're making these requests back and forth between the server and Facebook server. Does that make sense? So this is the high-level diagram here. So basically, if you want to use, so that the kind of take-home message from this diagram is that in your final project, if you want to use Facebook's API, what you want to do is your server-side code needs to somehow call Facebook's API by constructing HTTP requests and taking it back. So every programming language should have a library somewhere that you can import to make HTTP requests and then get it back. And because they're all just strings. So if you use Python, you use PHP, Ruby, you should be able to do this step. And once it's back, you need to do some more processing to filter the data or whatever, and you bring it back to the browser. Yeah?
So that is to say that the language written in the Facebook server and the language written in my server hasn't to be the same language.
Does not have to be the same language. That's right. Does not have to be. So Facebook server, I have no idea what their code is written. I think it's actually PHP. And you can be any. So that's a great point. It's completely independent of language. So the API is actually language independent, which is actually a really good difference between this and desktop, right? So a Python library will only work for Python most likely, and a Java will work for Java. But these web APIs work in any language. That's actually a good point you said, that I don't know what my server's written. I don't know what Facebook server's written. I don't care, because the way I communicate is through HTTP. So that's the common protocol we communicate. So you can use any language you want, and you don't care what Facebook is using. Okay, so now that we have a way of communicating HTTP, this will work. So if you read the API for Facebook, it will literally say to make, to get somebody's birthday or something, make an HTTP request for get facebook.com /user /birthday, blah, 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 and then we'll magically return you a string with their birthday or something. It's probably not how it works, but it's a simplified example. That's great and all, but the thing is, you have to construct all these HTTP strings, and it's really annoying. So this is sort of back to your C question, is usually languages will have, languages that are suitable for web programming will have libraries that actually help abstract out these HTTP requests. And they're called bindings for these APIs. So this is sort of the question of, you can make your web server in anything you want, but if you use C, you're probably going to be in a lot of pain, because C was not really meant for web programming. So you're going to have to do all this manually. You can use assembly language if you want. You can program machine code if you want, right? You can do whatever you want, but if you're programming machine code, you probably don't have these great libraries, and you have to write a billion ones and zeros. If you're doing something like Python or PHP or Ruby, it's probably equipped with these libraries that make your life a lot easier. So this is a API I found. I'm not saying you have to use Python, but this is the first thing I found, pythonapi.com. What this is I think this is a bunch of libraries in Python that allows you to create Python objects and use them to interface with Facebook or all these sites, Blogger, what is Carrots, whatever, eBay, blah, blah, blah. So these are all websites, right? Google Maps, GitHub, whatever. So if you use this library correctly, then what you can do is you can actually write Python code that looks on your server, that looks pretty reasonable. And when you make a function call in your Python code, it's actually making HTTP requests for you and back. So I'm sure these exist for Ruby and PHP and other libraries. So this is just a way of making your life easier. So before you choose to use one of these APIs, you should definitely Google around to see if there's a binding for your language. So let's see, Python Google Maps. This is what happens. I'm just going to search for it. Great. Google Maps Engine API Client Library for Python. Good. So this is if you want to use Python on your server to interface with Google Maps, you can use this kind of method to do so. So again, whatever tools you use, you should definitely Google around to make sure it's actually like there's a way to do it sort of easily. And this is kind of hard part of your project too, that you can in theory do whatever you want, but you probably want to look for stuff that a set of technology languages that make it reasonably easy and it's well documented to do. So questions before we move on? So we're getting basically into the land of, this is, from a philosophical perspective, this third part of the class is kind of hard to teach because it's really easy for it to devolve into just Google around for all these APIs and put them together. And there's actually no principles there. Also, if you actually look at the API references, I don't think anybody in the history of the world has ever learned to program in Java by reading these docs, right? Because no one has done, everybody, what you do is you say Java, basically, everybody, what you do is you say array list Java Stack Overflow, right? Append. No, really, this is what everyone does. Right there, bam, first link. How do you do this? You create one of these things, and it's actually pretty helpful, right? Way more helpful than this, right? So you'll find that as you're going to work with these APIs, these online resources like Stack Overflow are going to be super useful. And there's nothing wrong with using them as long as you document. Oh, I got it from this answer or whatever. Yeah.
At the same time, don't a lot of APIs have examples of how to use
They do, yeah. So well-documented ones should, right? So the Twitter one, let's see, do they have the examples? Yeah, so they have documentation and whoa, what the heck happened? They usually have some kind of getting started guide or tutorials and stuff made by the company. Yeah, so again, this is all kind of API quality, right? Because if you think about what an API is it's a bunch of code, but it's also documentation of how you use it. So, as a company, you have an incentive to make your API easy to use for people so that people actually use it. Okay, so we'll get into the second part here, which is actually looking at the details of APIs. So this segues well since we're on Twitter. So then the question is, how do you design these APIs and what do they really look like in detail? Because right now, the last half an hour has been pretty high level of here's a bunch of diagrams. But on a more concrete note, what will you be tested on? Because this seems like pretty abstract. So we'll actually go into this concept called REST, which is in your readings. So the idea is, how do you structure these functions or these kinds of methods? You can imagine structuring them in any way you like. But a term that's come up in the last 5 years a lot is this idea of this term called REST that you see in a lot of APIs. And this is, there is no right or wrong answer to this, because if you Google for REST APIs, you're going to get 10,000 different answers. But does anyone want to bravely start taking a stab at defining REST or what it is or how to use it and such? So admittedly, the one reading you had, that's not my lecture note because I just put the lecture note on, is not super helpful, but that's about the level of detail that everything on REST is, that they're all kind of vague. But do people, have anyone ever heard of this term REST in terms of web APIs? Good. And how did you hear about that term? Like in what context?
Oh, I was trying to use like the Jira API.
The Jira API, there's a REST API for Jira. What is Jira?
It's a way for if you're working in a company, you
Okay.
can track bugs in your
Okay, bug tracker. And there's a REST API, like a web API for interfacing with the bug tracker. Cool. Other ones?
Yeah, I was trying to get this Google Drive
Yeah.
thing for Linux to work, and then like the developer updated his blog. He's like, it's not going to work anymore. Google has this like new REST API.
Okay. Your thing won't work. There's a new REST API. Okay, good. Other
I
ones?
think for Twitter there is REST API and also streaming API.
For what? For Twitter?
Yeah.
Yeah. So Twitter has different kinds of APIs, but REST is one of the most common ones. Do you have ones up there? Just where people have heard of it, yeah.
I use Spotify API.
Spotify is an API that says it's a REST API. Other ones? Does it Connect actually have a REST API? Maybe it does. I don't know. Maybe. Okay, maybe it actually does.
You have to download the SDK.
Okay, so that's an actual library, yeah. Yeah.
I used it for REST. I was trying to dynamically create graphs.
Uh-huh.
For, geolocation.
Oh, good.
I was on the Google Maps one.
Using Google Maps.
API.
Good.
And then I quit.
Yeah. That's pretty much everything that. Any other ones that are out there? Yeah, this is a great sample. So basically, this is my experience as well. So when people hear about REST API, when I first heard of REST APIs, basically it's you try to do something on the web, you like see there's a REST API because it's just a term, like no one defines what it is, and then you rage quit because you can't use it. That's the story. So the story of REST is that what REST is it's the best way I can describe REST is that I would say REST is a style guide. That's what I would call it. It's a style guide for web APIs. I think that's the best way I can put it. So what's a style guide? So a style guide is like if you're writing, right? There's like the Chicago Manual of Style. There's Strunk and White. There's MLA. If you're writing academic papers, there's style guides saying you should use active voice, you should do whatever. Strunk and White's like, people have heard of Strunk and White, right? It's like a super old one. A lot of people don't like Strunk and White now because they say it's 100 years old. And if you actually read Strunk and White and write like that, you sound like you're from the 1930s or whatever. So there are newer style guides that say, okay, Strunk and White is right and somehow, but let's actually update it with new kinds of, LOL or whatever acronyms that we have now. So writing has style guides. So coding might have style guides, right? So if you're working at a company, they might say you have to use 2 spaces, or you have to use 4 spaces, or you have to use tabs, or you have to, put a space after your whatever, right? So the idea behind style guides that I really want to emphasize is that they're inherently subjective and they're conventions, right? So I'm not saying that you should not follow style guides because, for example, if you're working at company X, if you're working at Google, for example, it's actually public. So there's a Google style guide. What's everyone's favorite language? Let's say C++. It's like lots of groans. This is a Google C++ style guide. So if you're writing C++ code at Google, you need to follow the style guide, or else when you're getting code reviewed, people are going to yell at you. So there's all these things that are styles, like use this, use these spacing, use these names, use these things. Google made their style guide public because it's it's just kind of useful to kind of see their standards, because I'm sure a lot of this is good and it's kind of known to be best practices and stuff. But the thing is, you can write C++ without following this, right? As long as your C++ code compiles, you're good. But if you're working at Google, you want to follow the style guide, not just because you want to keep your colleagues happy, but because you want all the code you're at Google writes to look the same, so that when some new engineer comes on, they can read it and understand it. So imagine you're reading 10,000 lines of code, and like one function just looks completely different than everything else. You get super annoyed, right? So style guides are there for that reason, but they're not laws, right? You're not gonna get fired if you. Well, maybe you will, but they're edicts. They're not edicts. So writing's another one, right? You could write perfectly grammatical English that if someone reads it as a native speaker, it might sound weird or off or such, but it completely is proper grammar. All the words are defined right, but there are style guides saying here's how you write good English for academic writing or for a blog post or for a marketing press release. Anyway, so this is a long way to say REST is a style guide for web APIs. And what it actually is that it's a style guide that makes it so that these web APIs roughly look somehow, clean. So the way to think about this is by following these REST principles, which you can read about in your readings and the lecture notes, your APIs, the URLs you generate from your API look sort of sensible and not super weird. That's the best way to put it. But let's actually just do this by example. I'm just going to do it by example by writing out some APIs. So we're going to make up an API here. This is all, let's do new file. This is all just made up. This is all in the lecture notes. This code won't actually run. So let's say you want to make an API for, let's say you're making Facebook, version 0.001, whatever. Okay, so a normal web app, just like the one you're going to do for your class project, you want to make what's called a CRUD web app, right? Facebook CRUD, this is good. And CRUD stands for create, update, wait, that's CRUD. Read, update, and delete. So this is what you think of as a normal web app, and you should do this for your project. So what do you want to do for your simple Facebook? You want to be able to create a new user with, say, name, job, pet. Let's just say your version of Facebook has 3 things. You want to read a user's profile. You want to update a user's profile by adding by changing their job or pet, right? You probably don't want to change their name because the name is the unique key. Let's just keep it simple. And then delete a user's profile. So this looks like a pretty good specification for the first version of Facebook you make, right? There's no pictures or no anything. So this is a CRUD app, right? You want to create, read, update, and delete. So how do we go about doing this? Let's say you want to actually expose an API at Facebook so that someone could make HTTP requests to do all these 4 things. Because if you can do those 4 things, you can write a Facebook app or something, right? So the version 1, this is all going to be your notes afterwards. So it's good to see this now, but you can read this afterwards as well. So I'm just directly going. So version 1 is not REST. So just to recap where we are here. So examples of web APIs, this is great. We've shown a ton of them. Let's build a simple web API, and we're going to do 3 versions: version 1, version 2, and then finally version 3, which is REST. So version 1 is the simplest API you could make for your site is to have one single script. So one single script to do everything. That's the simplest thing you can do. Just, that's how you create hello world. I just have one script. And the script I'm just going to call dostuff.py. Py just because we're writing in Python. That's what we're going to do. We're going to have one script do everything that our API requires. So recall that API we need to create, read, update, and delete. So to do this, the script is called dostuff.py, and we're going to visit facebook.com/dostuff.py. This obviously won't work. It's not a real link. But let's say we had Facebook and we're making the first version, and we have one Python script. That's a CGI script or whatever you learned from the first part of class. We have one Python script called dostuff.py, and we want to just use this to do every operation. So how do we do that? So how would we create a new user? So to create a new user, what the specification, I'm just writing the API, right? The API is, I can make whatever up I want because I don't have to actually code it. So you write the API and then you get your friend to code it or something, or you code it yourself. So create a new user. So the specification for create a new user is the following, is post. So make a post request to Facebook. I'm just going to call this FB. I think Facebook owns FB.com, right? Hopefully. So I'm just going to call this to be short because I don't want to type so much. Post to FB.com, and the body of the post is operation equals create, and name equals Philip, and job equals professor, and pet equals cat. I don't actually have a cat, but let's just say I did. So what does this mean? This means that in order to create a new user, to create a new user, if someone has a script to do that, what they'll have to do is they'll have to create an HTTP request called a post request. They're going to visit this URL, and the body of their post, they're going to pass, 4 parameters, right? Operation equals create, name equals Philip, job, and pet, and whatever. So recall that post, you want to pass all the parameters in the body, right? That's the difference between post and get. That's from exam 1. If it was a get, you would be able to do a question mark. So does anyone know why we want to use a post and not a get here for this API? From exam 1. Yeah, you're creating something new. So get is usually something used for getting an existing resource. And the practical implication is that gets can be cached. So you might actually not ever execute this code if it's a get, because if you executed before, you might not actually execute. So you should definitely use post for anything that creates something new. So anything that's creating something new, you want to use a post. For simplicity, we just want to use post for everything because we don't want to worry about caching. But you could use post for everything. So this is how you create a new user. I obviously haven't implemented the code, but in order to implement this code, you can imagine in dostuff.py, I take the parameters from post, from lecture 4 or whatever, I parse them, and what I do here is my script sees that operation is create, and then I run some code saying if, in my Python code, it's if operation equals create, blah, 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 right? And that blah, blah, blah is I'm going to create a new row in my database with name, job, and pet, and put it in, and I've created a new user. So questions on that? So that's our first API call right there. Yep.
So body is what Facebook gives back to you after you submit.
Oh, no. The body is what you submit to Facebook. So this is all the requests. this is all your request. So you submit the post and the body. So remember how when you make a form, you have to, when you submit the post, the parameters go in the body of the post. This is all your request. Facebook will give you a response. This is actually really good. I didn't think about the response. The response could just be okay or no. All right. The response could just be a string with a status, okay or no or whatever. Yeah. So the API should actually specify a response. I just didn't worry about it for now. But so do you have a question for this?
Yeah, so those variables, are those variables going to store in the field storage?
That's right. So in Python, they're stored in field storage, just like all the example code. So you can access it from your Python, well, whoever made this do stuff in Facebook needs to get field storage and do all this stuff. That's right. That's from lecture 3 or 4. Okay, so the other ones are similar. So the key here is that you pass a parameter called operation create. So let's do, what is it, read user's profile. Let's actually put a response here. So response is okay, or error if the server broke or something. So to read the user's profile, what we want to do is we want to say something similar. We want to say post do stuff operation equals read. These are not very creatively named. Name Philip. So this says I want to post to this script, and I want to pass the operation as read, and the name, what user you want to name, you want to read, is me. And now the response is actually something more interesting. It could be a JSON thing. So the response is name. Probably don't have the syntax right, but job. Pet, cat. So now what the server gives me, because I'm trying to read my profile, someone's profile, I request an operation read with name Philip, and the response is my profile in a JSON format. So questions about this? So this is reading data from the server. We use JSON because it's what everyone uses now. So we have the create and read. So let's do update, which is the same thing pretty much. We don't need a response. The response could be okay or whatever. We'll say operation equals update. This is not very creative. Name equals Philip. So that's who I want to update, and I want to pass a new job equals, I'll say cat wrangler or whatever. I don't know what I used for my example. Cat herder. So now what this will do is if this is successful, then if I try to read my profile again, it should say cat herder, right? Because this update, once it runs, that means I've changed the database. So this should be a post because I've changed the database. Then when I read again, my pet or my job is now cat herder, whatever. And then finally there's the delete, which as you can imagine is the same looking thing. So request operation delete. And then you need to know who you want to delete, right? So name is Philip. Okay, so this makes sense? So this is an API right there. I've made my first Facebook API. It's awesome. It works perfectly. There's one script, and it does everything. And this will work. I mean, if I publish this on Facebook and say this is the Facebook API, people are like, okay, I'll use it. It's fine because you can't use anything else. And it has one script, or kind of imagine one function. And depending on the body of the post, the operation, it does different things. So what are some of the issues with this API? So this is version 1. So correctness, it actually works. So we'll assume it works. We'll assume I coded or someone else coded it and it's fine. So it has no correctness problems because it actually works. It does everything you want. So what are some of the possible issues with it? Like what might irk people if they use this? I mean, there's no right or wrong answer. This is all subjective. Again, this is all style, right? Yeah?
What if there were more than one person named Philip?
Yeah, so that's part of the, so we'll assume it's correct. This is part of the database. So we'll say it's unique. So you can imagine username, right? So Facebook has username. So yeah, that's part of the database. But just this interface, yeah?
If they're all sending a request to the same place and it's not multi-threaded, you can get traffic issues?
That's a good question. So performance can be an issue is that everybody is just calling the same do stuff script. So you might want separate scripts, right? Because I'm reading data, someone's deleting data, it's all going through the same script. It seems kind of weird. So that's a good one, yeah?
It's also usually most of the times considered bad style to have an operation field that changes what it does. Generally, you won't have a different thing to call.
Perfect. Yep. So these are all styles. So this is like this API I wrote in my notes is like if you have. So this is the Java API. All right. So remember the real Java API may be a little extreme because it's so giant. The Java API is extremely, okay, whatever. It's extremely giant. But let's actually make a really simple Java API. The simple Java API is I have one function. Done. That's my API for Java, right? And how do you do stuff? You pass in an object with some parameters, and depending on operation, create a list. It'll create a list, operation, whatever. You can imagine the Java API having one single function, but that's probably not going to fly because people get super annoyed with you. You probably want a different function for each thing. So that's the main downside of this, is that you have one function essentially called do stuff, and that's a pretty bad API choice. Even though it works, it's probably going to look pretty bad. The third one, which is a little subtle, is about caching. Is that in fact the read operation? Where's read? The read a user's profile. This can be cached because it should be a GET request, because assuming nothing else changes, you can read from the cache. But because my API says everything is post, because there's only one function of post, I can't actually cache the reads. So it's a subtle thing. All right, let's do version 2 before we go on to the rest one. So version 2 is exactly the same thing as version 1, except we're just going to make 4 scripts. So version 2 is, I'm just going to copy. Blah, 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 blah. The magic of copy and paste. So version 2, so version 1 is clearly not REST. Version 2 is still not REST. But let's just make 4 functions. So let's do, create user? So now I have a special script just for creating user. So this is going back to your suggestion. So that's good, because now we no longer need operation in here, because I know that I'm creating a user. So that's perfect. So what are we creating user with? Name, Philip, job, whatever. So how do I read thing? I'm going to make another script called read user. And again, I don't need an operation. So notice now my parameters are getting simpler, right? Because that information is in the script itself. Update, we'll do the exact same thing. Update user. We no longer need an operation. And then finally, delete user and name Philip. I'm going to make this a little bit more concise, just to get everything squeezed down here, so we can see it side by side. Whatever. We don't need this. We don't need these. These are all requests. So if we stare at it, actually, let's do that. The read can be a get now, right? Because now we have its own self. So we have a get. And now instead of passing in the body, we can just pass it directly in the URL. Because remember, gets the parameters in the URL. It's a small difference. But this is our version 2 API. This is actually looking a little better, right? This actually is looking somewhat respectable. Still not REST. Okay, version 2 API. We have 4 functions now. Create user py. Oh, sorry. Read user.py. Oh, no, it is. My thing is over wrapping. So create user, read user.py, update user py, delete user py. And now notice the parameters are smaller because you no longer need the operation field. This is version 2 of our API. Again, this will work. This is the exact same thing as version 1, except now it looks a bit cleaner because I have 4 separate scripts. Each script does one thing, so it seems a little nicer. You don't need the parameters. And also you have an optimization because the get can be cached, because these are all posts in the API and this one is a get. So this is what you would, in what you've learned in class so far, you're able to get to version 2, because you're able to create 4 Python, you probably have to put it in CGI bin or whatever, but you're able to create 1 Python script or 1 whatever PHP script for each operation, and then you write your documentation, you're saying, go and if you want to create a new user, call create user.py with these parameters, call this, call this, call this. So this API looks like you have 4 functions. You have, this is not a perfect analogy, but it looks like you have 4 functions, right? I always forget read, curd. Delete user. So this is a lot better of an API than do stuff, right? You have one thing. Imagine you have 10 functions. Okay, so why are we not ending the class here, and why do we have 5 more minutes? Because we want to do version 3. So finally, version 3 is the REST API. So this actually looks just fine. I mean, it works. There's a separation of concerns. You can code it pretty easily. It kind of works. This is going back to the whole style guide issue here, right? Of this here is this here. Is that there are some people that are pretty opinionated about this to varying extents, and it so happens that this has now become the predominant way of doing things. So the thing here, if we actually look, let's forget, we'll have the body. What is in common with these URLs is that these URLs look like verbs, right? If you actually read these URLs off, well, I'll just put it 4 times just to drive the point home. What these URLs look like is they look like verbs, right? If you read the URL off, it looks like I'm creating a user, I'm reading a user, I'm updating a user, I'm deleting a user. Okay, that's fine. They look like verbs. Why is that weird? It's kind of weird because when you think of a URL, you think of URLs as nouns if you're a purist. Because if you think about it, if you think about facebook.com, I don't know, profile.html, that's a noun, right? Profile.html is a noun. It's an HTML file. It's something you can hold in your hand. These are obviously not real URLs. Cat.jpg, that is a noun. That's a picture of a cat. This is, skating. I don't know, AVI or whatever. I don't know what video formats are, MP4 or whatever. That's a video, right? That's a noun. That's a thing. It looks really weird if all these URLs are nouns, but these are verbs. Like, this has irked many, many people in their lives. Even there's nothing wrong with that. I mean, they're verbs, they're nouns, whatever. But if you want the web to be a uniform, kind of beautiful place, you want every URL. So in the REST style is every URL should be a noun and not a verb. That's a big part of it. So then the question is, how do we possibly turn these things from verbs to nouns without making them to gerunds or something? You could say user creator or something, which is a, that doesn't count. That's just cheating. How do we turn these into nouns? And the way to do it is to create an API in what's called a REST style. And this is it right here. I'm just going to write it out, and then we'll explain it. So to create a new user, so let's erase this. I'm just going to erase this. This idea that these URLs we know so far are verbs, which is weird because every other URL we know and love are all nouns. So we want to make URLs into nouns. So how do we do this? So let's do create. So to create, what we're going to do is we're going to make a post request to fb.com/body. Capitalize, whatever. Okay, so what the heck just happened here? This is the API right here for create user. What just happened?
You create the user, you need to fill up with all those specifications, JavaScript specifications.
That's right. That's what we wanted to do. Why does this URL look weird? I mean, it doesn't look weird, but why does it look different than all the other URLs? I mean, first of all, this is a noun, right? Yeah. It ends with a slash. Good. So what do you think of things ending with a slash being? Folders or directories, right? This looks like a folder. This looks like a user's collection folder directory, right? This looks kind of like a folder, and it's a folder of users. So what this is saying is that, first of all, there's no Python script here, whatever. We'll get into other lectures. How do you actually implement this? Let's not worry about how to implement this. Let's say, pretend this works. This is just a specification. This actually reads sort of like English. And if you read in English, it says post means post some data. It means post some data to Facebook, to the users folder. And I'm going to post a data, which is this, into here. So the URL is a noun. But the verb comes from this, right? So the verb here, this is like a grammar class. Verb is post, and noun, which is I haven't taken grammar in like 20 years, so it's called the direct object, right? Is that right? I hope someone here is an English major can tell me. I don't know if I remember what gerunds are, but I think it's a direct object. The verb is post, the noun is the URL. So the noun is the URL. This fits the REST philosophy, or part of it, because now we've actually made our API into noun-oriented URLs instead of verb-oriented. So that, in theory, someone can read this request saying, post to this noun, do something to this noun with this data. So I'll give you all the other ones so you can see what I mean. So to read is to do get. This is the simplest one. Did I capitalize my name? I think so. That's it. So this is the read a user's profile. So this is the most elegant looking one because all we do, the verb is get, and the noun is my URL right here. So this actually starts looking pretty elegant because really to read my profile, all I want to do is say this. I want to get facebook.com/user/Philip out of there. Yep.
That directory be a database?
That's right. So the thing that we're hiding from you here is that this looks like what? This looks like a directory, right? This looks like a directory, and this looks like a what? A file name, right? This looks like a directory. This looks like a file. So conceptually, in the concept world, in the kind of the concept world, it looks like you're getting a file out of a directory. And what I want my profile. I mean, the file contains my profile, right? But in fact, as you kind of hinted at, these things don't have to actually exist on the server. These URLs can be fake. And your web server software can know how to translate those URLs and call a database and do everything. So I don't want to get into this time so when you hear about web application frameworks, that's a big part of what web app frameworks do. So in what you've learned so far in the class, you cannot actually do this, right? Because so far what you learned in the class, you can't implement this because you actually need a real file named Philip and a directory named users, and you can't actually access profiles. So we'll go over this later, but pretend like you can, yeah.
Like in the past, we know that what we should do, like because we have a Python script, but now, like you just give us a folder, but why the folder knows what to do?
Right. So we'll get into this in 1 and 2 lectures, which is it knows because your magical Python script actually parses that URL and knows. So I'm going to finish. I have 1 minute. I'll finish with the 2 parts of the API. So update is we're going to do put p.com/body is job equals cat herder, and delete is. So that is the API right here. So whoops, let's make everything really compact. What just happened? Sorry, I'm going to put it. So this is the whole REST API. So create, read, delete, update. So if you read this in English or in quasi-English, there is a special delete HTTP request. That's the verb. I want to delete the user's Philip. By doing this, my magical web application framework does the database stuff and does it all for me. To do an update, people use what's called a put request. You can also use a post. I am putting, which means I'm updating Philip with a new parameter, which is job cat herder. So if you actually look at the readings, I contrast this version with that version. But in short, the REST API, again, this is all stylistic, right? You can write however you like, but this is what people say as a REST API, that it looks like the key takeaway point from REST API is that the verbs come from the HTTP types, and the URLs are all nouns. And that's pretty much, I mean, there's a bunch of other details on REST, but the important thing to get from this class is that that's how REST APIs are structured. So that when you actually look at the APIs for Twitter, they all look like that. Yeah?
Are the HTTP types still a closed class?
I think so. I think there's only like 6 of them or something. Most people just use these 4: post, get, put, and delete. So with that, I'll see you all on Thursday. We're going to cover a completely different topic.